Hello guys, today we're going to just review some of the Newton laws that we've learned this week in kind of a fun way. We're going to be doing some stations, which are a little bit more challenging online, but we're going to work through it, and I'm going to just explain what I want you guys to do today. So first and foremost, always to get our brain thinking, the first thing is our question. So what is Newton's first law of motion? Does anyone, just to try to get your brains to think, is there anything you remember from us learning about it? Of course, it is an object at rest stays at rest, while an object in motion stays in motion, unless acted upon by an unbalanced force. What about our Newton's second law? This one's a lot shorter. The definition that we used is that force is equal to mass times acceleration. That's our second law. And our third law is for every action, there's an equal and opposite reaction. So we're going to go through each one of these and kind of break them down as we review them, but our objective today is just to complete our stations to help us learn each Newton law a little bit better, and then, of course, to have fun. So our stations, we're going to have three different stations. Our first station is going to be dealing with this idea of a card getting pulled across like this, getting pulled across the cup, and then looking especially at the coin to see what happens with the coin. And then our other one is going to be dropping some balls like we have up here and seeing what happens to the ones on top. So our second law, what we're going to be doing is going through just some example problems on how to calculate if we want to find our force, our mass, or our acceleration. And then our last one, and I think our most fun one, is we're going to try to do some balloon cars. So we'll be making cars which are powered by air from a balloon. And then we're going to be using them to explain our third law and trying to figure out how they work. Of course, our balloon pushes with a force one way, and our reaction is the car moves forward in the opposite direction, is how we get this to propel forward. So with that being said, what I want us to do today is I've made this nice Jamboard to go through it. So it has everything, I think, outlined or described well, but what we're going to be doing is each of these stations. If I've attached a bunch of videos, but if you guys have the materials at home, I would love for you guys to do this in person. I think it's always better to be able to see things and do them yourselves, but if not, we just have some videos. So the idea is if you want to do this in person, you don't need to watch a video. You can go find a piece of paper and a coin and a cup. I'm sure we all have that lying around the house somewhere. And then I want you guys to practice pulling the card across the cup at different speeds and seeing how the card moves. So if we pull it slowly, what happens? If we pull it fast, what happens? And if we don't have the materials, I have this video right here for us to watch. And then every time I want you guys to answer something, I have these little sticky notes. So for this one, our question is, as they pulled the card away, what happens to the coin and why? So your guys' answer to my question should go right in this sticky note, and you'll be able to edit this part. The same thing with this one. If you guys have maybe a soccer ball and a tennis ball, please go try this and try to put them on top of each other and then see if you can get them to bounce up in the air higher than they would just on their own. If not, you guys can watch this video. The link is right here. And then answer the question, why do the balls go much higher when they're stacked on top of each other, right in our sticky note. For our second law, we just have some examples to go through. So this picture does a really good job of saying that our force is equal to our mass times our acceleration, or is what our second law is. If we do some rearranging, and we can use our triangle, we can say our mass is equal to our force over our area, m is equal to F over A, or even that A is equal to F over M. So if we're trying to solve for our force, we'll use this first equation. If we're trying to solve for our acceleration, we'll use this third equation. If we're trying to solve for our mass, we'll use this one. So it's as easy as just plugging our numbers into our formulas, using the right formula, and then I just want you guys to put your answers here, and then make sure that your units are in the right ones. Those are always important to have our units correct. And then our last one that we're going to be working on is Newton's third law. So I want you guys to watch this video which explains how to build your own air balloon car. I know this takes a little bit more materials, but if you have a balloon, a straw, and there's a bunch of different ways to do the caps on our car, our wheels, I should say. If you have anything that you can make work, I'd really encourage you. I think this is a really fun way to learn about Newton's third law. And then our question here for this one is, what is the action and reaction of the air balloon car? So that'll be your answer right here. If you guys have any questions about completing this, please let me know. Really what I want you guys to do at the very least is just answer each one of these sticky notes. So every time we have one answer here, 3 answers here, and 2 answers here. So really we just need to do 6 different answers for today. But the more you are able to do it on your own, I think the better it will stick and the better you will learn it. So good luck if you guys do end up making a car or any one of these, doing these. Please take pictures. I'd love to see your guys' work and what you guys come up with. So, of course, if you have any questions, let me know.